We'll show you another method to estimate the coefficients in a multiple regression. It's a bit more complicated mathematically, but it provides insight into the workings of multiple regression and how to interpret the parameters. This method involves partialing out. Suppose we have a multiple regression model. The betas are indexed by j, which ranges from 0 to k. We're interested in beta 1, which describes the relationship between y and x1. Step 1 is to estimate a regression of x1 on all other regressors. Step 2 is to regress y on the residuals from step 1. The residuals are everything that explains x1 that's not captured by the other regressors. According to the Frisch-Waugh theorem, delta 1 will equal beta 1 from the original model. The process can be applied to any other regressor, beta j, that you're interested in. You may ask, I already know OLS. Why are you showing me a longer, more complicated way to estimate beta j? The reason is that it provides insight into the meaning of beta j in a multiple regression. The usual interpretation is that beta j is the expected change in y associated with a one-unit change in xj, after controlling for all other factors in the regression. The partialing out method demonstrates what controlling for all the other factors means. Essentially, when we estimate beta j, we first isolate the variation in xj that isn't explained by the other factors. There must be something left, because otherwise, we'd have perfect collinearity, and we assume we don't have perfect collinearity. The residual variation is what we actually use in the multiple regression to explain y. Then by regressing y on R, delta 1 represents the isolated effect of xj on y that doesn't pass through the other regressors. Why is this useful? Suppose we want to know the factors that determine income. We believe that education is important. We also believe that the industry in which you work is important. If we want to know just the effect of education on income, we don't want to confound it with the effect of industry on income. However, education can also influence the industry in which you work. For example, it can open doors to professions such as medicine. By using multiple regression, we can separate the effect of industry from education and focus on the specific impact of education that doesn't pass through industry. For more lessons on econometrics, visit alphas&betas.org.